Hello my dear student, welcome you here in this lecture number 58 for that topic Haloalkanes and Haloarenes. Now we have studied in detail regarding the optical isomerism, optical activity, enantiomers and all. So we know that a property of organic compound to rotate the plane of vibration of plane polarized light either towards right side or towards left side is known as optical activity, and such compounds are called as optically active compounds. And optical activity is not a general property. I have given that statement, but it is shown by very few organic compounds. Only that organic compounds which contain chiral carbon atom, at least one, or asymmetric carbon atom, at least one. And what is asymmetric carbon atom? Which is joined with all four totally different atoms or groups. A chiral carbon, that is particularly asymmetric carbon or chiral carbon, is that which is bonded with four all together different atoms or groups. That is optically active. That can only show optical activity and optical isomerism. Okay. Second एक character उसमें और दिया था. What is that? Presence of the structures of two isomers should be related to each other as object and non-superimposable mirror images. That means if one structure is lifted up and placed on the other, all similar groups should not coincide. So all this part we have discussed in the earlier videos, you can check that. Now we have to apply this all optical isomerism with that optically active alkyl halides in SN1 SN2 mechanism. Product में कैसे changes होते हैं वो हमें देखना है. Okay, so it is said that SN1 and SN2 mechanisms for optically active alkyl halides. अब ये 2' ब्रोमो ऑक्टेन जो है उसे माइनस दिखाया जाता है. What do you mean by minus? That means it is levorotatory. Plus means what? Dextrorotatory. ये एंटी क्लॉकवाइज डायरेक्शन में घुमाएगा प्लेन पोलराइज्ड लाइट को. अब 2' ब्रोमो ऑक्टेन का फॉर्मूला क्या लिख सकते हैं आप? ये CH3 CH Br दो हो गए, देन CH2 CA. अभी ये कितना लिखना पड़ेगा? 6. दो हो गई है. ओके, यानी वी हैव टू राइट CH2 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 कितने हो गए? 1 2 3 4 CH2 5 एंड देन CH3. ओके, क्या आठ देखो 1 2 3 4 5 6 7 8 करेक्ट है. 2' ब्रोमो ऑक्टेन. ओके, पर ये इतना हर बार लिखना जरूरी नहीं है मेरे ख्याल से. उसको हम कंडेंस कर देते हैं. 1 2 3 4 5 6 कार्बन, और ये 8 and 3 11. 1 2 3 4 5 5 into 2 10 and 3 13. So C6H13. So इसको मैं ऐसा भी लिख सकता हूँ CH3 CH Br C6H13. Now you will notice that carbon number 2 is asymmetric or chiral. ध्यान में आ रहा है मैं ऐसा क्यों लिख रहा हूं? So that all four groups are totally different. This carbon number 2, ये carbon number 1 हो गया, ये carbon number 2 हो गया. Okay, carbon number 2 is chiral carbon. That's why it is optically active, isn't it? तो इसका भी मैकेनिज्म कैसा हो जाएगा? अगर हाइड्रोलिसिस करेंगे OH में ऐसा आ जाएगा तो कैसा हो जाएगा? So particularly one bulky group is there, no doubt. This is secondary bromide हो गया, ये secondary alkyl halide हो गया, but that can follow SN2 mechanism also. अब समझो इसका SN2 mechanism हो जाएगा तो क्या हो जाएगा? Can you tell me? Now I will write this carbon particularly with this CH3 Okay, suppose that this is CH3. कौन सा भी ग्रुप कहीं भी लिख सकते हैं आप. You can add any group anywhere. Yeah, suppose that this is C6H13. Then suppose that this is their hydrogen. This is their CH3. Okay, CH3, CH, C6H13. अब रह क्या गया? That is of the same plane. Suppose Br. Okay. Now here, if it is reacted with aqueous KOH, then OH minus ion nucleophile will have backside attack and that is okay. एक बल्कि ग्रुप है पर तो भी यहाँ पे जगह है. And this will show backside attack. Okay. And when backside attack is there, then it will be SN2 mechanism. ये जो है that is minus 2-bromo-octane. 2-bromo-octane. It can undergoes SN2 mechanism. SN2 mechanism. Okay, ये ध्यान में रखो. तो क्या हो जाएगा? Now what will happen there? Backside attack will be there, you know, slowly. तो ये कार्बन आ जाएगा, फिर that will be that last, you know, this carbon is there, then this is particularly the hydrogen. Okay, then another will be the that CH3, and then another will be the that what particularly what is it, that 6H30, C6H30. Okay. And now what will happen? This bond will be broken simultaneously. Br delta minus and OH will be there delta minus. This bond will get formed simultaneously. Okay, but this is very, very unstable. This is unstable transition state. Unstable transition state. ये अनस्टेबल ट्रांजिशन स्टेट हो जाएगा. ओके, एंड नाउ व्हेन Br इज कंप्लीटली लॉस्ट इन द सेकंड पार्ट ऑफ दैट रिएक्शन, ये पूरा का पूरा रिवर्स हो जाएगा. COH विल बी फॉर्म कंप्लीट बॉन्ड, देन हियर यहाँ पे C6H13 ऐसा आ जाएगा. नीचे वाला ग्रुप कौन सा था? C6H13 हेक्सिल ग्रुप. बीच में वाला कौन सा था? दैट इज हाइड्रोजन. ओके, और ये सामने वाला कौन सा था? दैट वाज CH3. सो एग्जैक्टली अपोजिट, ये जो स्ट्रक्चर है उसके एग्जैक्टली अपोजिट स्ट्रक्चर बन गया. SN2 में इन्वर्जन ऑफ कॉन्फ़िगरेशन हो जाता है. ओके, अब इंपॉर्टेंट बात ऐसी है दैट दिस इज पर्टिकुलरली ऑक्टेनॉल 2-ऑक्टेनॉल, ये अल्कोहल बन गया अभी. एंड दिस इज विथ इन्वर्जन ऑफ कॉन्फ़िगरेशन, 100% inversion of configuration. And if inversion of configuration is there, then non-superimposable may form. ये स्ट्रक्चर नंबर 1 एंड स्ट्रक्चर नंबर 2, ये नंबर 1 का स्ट्रक्चर है, ये नंबर 2 का स्ट्रक्चर है. They will be non-superimposable mirror image. The side to which CBr was there, now exactly opposite side COH bond is there. 100% inversion of configuration. So no doubt because of that what will happen, optical activity will be also reverse. वो भी reverse हो जाएगी ना. सही है. If this is showing levo rotation या levo rotatory, then this will be डेक्स्ट्रोरोटेटरी. ये प्रोडक्ट कैसा बनेगा? डेक्स्ट्रोरोटेटरी, यानी टोटल डिफरेंस. तो ये कैसा लिखेंगे हम? प्लस, यानी डेक्स्ट्रोरोटेटरी बन जाएगा. इफ दिस इज माइनस, द प्रोडक्ट रिटर्न विल बी प्लस. So in SN2 mechanism, what is the brief summary here? Whenever alkyl halide which is optically active will undergo SN2 mechanism, the product will show exactly opposite optical activity. ये बात ध्यान में रखो. If reactant is levorotatory, product will be dextrorotatory, and vice versa. If product is dextrorotatory, reactant will be levorotatory. So in SN2 mechanism of optically active compound, the product form will have exactly opposite optical activity, 100% product with inversion of configuration. और ये क्यों होता है? Because of the backside attack of nucleophile. So I am confident that you must have understood this concept very properly. We learn the example of SN1 reaction for optically active compound in our next lecture. Till then, take care. Thanks a lot.